Hello everyone, this is Cavell speaking, and today I'll be talking about scientific notation. So it says, for scientific notation, the numbers in scientific notation, if it is written in the form a times 10 to the n power, where a is greater than or equal to 1 and less than 10, and n is an integer. Okay? So what's the purpose of scientific notation? Well, scientific notation is used to represent really big numbers and really small numbers. Okay? So let's go through a few examples, okay, of what it means. Okay? But before we do that, right, let's talk about the powers of 10. What's so special about power of 10 is that we have 10. Oh, sorry. Make this a little bit darker. I have 10 to the n, right? So if n is equal to 1, I just get 10, right? N is equal to 2, I just add another 0, so it's 100. N is equal to 3, it's going to be 1,000. Okay. So depending on what the n is, right? Whatever the number n is, that's going to tell me how many zeros I'm going to have next to 1. N is equal to 4, right? What happens? I got 4 zeros. Right? If n is equal to 5, I get 5 zeros. Now if n is equal to 0, right, that's just 1. Anything to the 0 power is just 1. N equals -1, right? I basically have 0.1, right? And in retrospect, right, what you're essentially doing is you're moving the decimal place, okay? So when you multiply by a power of 10 that is power n that is greater than 1, right, greater than or equal to 1, right, you're going to be moving your decimal to the right. And if you are multiplying by a negative exponent, right, of 10, your number's decimal is going to move to the left. Okay, so let's see some examples. Okay, so the first thing we're going to do is we're going to I guess in a sense translate and convert a scientific notation into a regular number. Okay, so let's look at this first example. Let me just delete this so we have some room. So the first one is 3.46 times 10, right? 10 to the 4. Okay. So the first thing we gotta do is write down the number 3.46. Okay. And then we look at the exponent, right? So the exponent with the base 10, and it's 4, right? My exponent is 4. That tells me my number is going to get bigger, right? And when my number is getting bigger, does my decimal move left or right? Well, it moves to the right. Well, how many times? Well, the exponent tells you how many times. So if it's raised to the 4, I move it 4 times to the right. If it's raised to the 5, I move it 5 times to the right. So now it's raised to the 4. So I move the decimals 4 times to the right. So 1, 2, 3, 4. So that's where my new decimal is going to be. Okay. Let me just erase this. Okay. And within these decimals, right, I'm going to put in 0 in the places. So that's exactly what it means. Okay. So what does that mean? That means that 3.46 times 10 to the 4th power, right? Let me get rid of this dash on the bottom. 3.46 times 10 to the 4 is 34,600. Okay? Let's do another example. Okay? Let's just say I have 6.78 times 10 to the 6. Okay? Remember, once again, I write down the decimal, 6.78, right? And I ask myself, how many times do I need to move the decimal? Well, I look at the exponent. Exponent says 6, so I gotta move it 6 times. So I look at the decimal, right? And it's a positive exponent, right? So I gotta move to the right. So 1, 2, 3, 4, 5, 6. That's where my new decimal place is gonna be, right? Once I have that, I can get rid of this decimal. And I just replace it with zeros. Okay, so my new number, right? Once I delete this, is 6,780,000. Okay. Sorry, not 780,000. 6,780,000. Sorry about that. So this is my number, right? So as you can see, we can represent really big numbers using scientific notation. Okay. So now let's deal with an example where the exponent is negative, right? So these are all what? Positive exponents. Okay. And the reason why we use 10 and not, let's just say 2 or 12 or 3 or 4 or 6 is because when we multiply it by 10 to a decimal, or sorry, 10 to a integer, right? We can simply just move the decimal place either left or right, depending on if the exponent is negative or positive. So these are positive exponents, okay? Positive exponent. Now let's do negative. So our next example is 1.89 times 10 to the negative 3. Okay. So same idea. Rewrite the decimal that we're given. And now if you think about it, right? When we're multiplying by 10 to a positive exponent, what happens? Our number increases, right? So our decimal moves to the right. Now when it's negative, our number gets smaller and smaller, right? The same thing applies. So negative 3, so you have to move the decimal place 3 times to the left. Why left? Because our decimal is decreasing. So once again, look at the decimal, and we count to the left 3 times. So 1, 2, 3. Alright, replace each spot with zeros, right? Let's erase the original decimal point. And this is my new decimal now. Okay. So this is basically 10 hundreds, thousands, 10,000, 100,000. So it's 189 thousandths. Okay. Let's do one more example with negative. Or at least one more example. Just to get the hang of it. Okay. Let's just say we have 1.25 times 10 to the negative 8. I'm going to be writing my decimal all the way out here just to have some room. Once again, it's a negative exponent, so my decimal is going to be moving to the left, right? The decimal point is going to move to the left. And since the exponent is 8, I can move it 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. So this is my new decimal. Place it with zeros, 0, 0, 0, 0, 0. Okay. And then we just delete these lines. Obviously, when you do this by yourself, you can write the lines just to help you. But do not forget to erase or delete the original exponent. Alright, so this is my new decimal. Okay, so this basically represents this. Obviously, this will represent something that's very, 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 very minuscule, very small, right? So these are negative exponents. Okay. So remember, negative exponents move to the left, positive exponents move to the right. Okay. So let's see if we can convert some bigger small numbers into scientific notation. Okay. So this is converting scientific notation to regular numbers. Now we gotta do the opposite. Okay. All right. So the first set of questions, it says the number can be written in scientific notation as 6.93 times 10 to the n. Find the value of n. Okay. So 6.93 times 10 to the n. Okay. Number 1, I have 693. Right. So remember, it's always 6.93, right? So, but I just have to ask myself, how many times I have to move the decimal point to make it look like this number, 693? So if I want to make it look like 693, I have to move the decimal place how many times? 2 times, right? 2 times to the right. So that means 693 is 6.93. Remember, if I move to the right, that means my exponent is going to be a positive number, right? And how many times did I move it? Well, I moved it twice to get to 693, so it's going to be 10 squared. Okay. Number 2 says 69.3. Okay, same idea, right? 6.93. How do I get 6.93 to look like 69.3? Well, I gotta move the decimal to the right once, right? So that means, once again, it's going to be a positive exponent, right? And how many times did I move it? Once, so it's just going to be 10 to the first power. Okay. Number 3, we have 0.0693. Okay. So once again, all right, we need to ask ourselves, all right, how many decimal places do I gotta move this to look like this? All right. So we have 6.93, right? We can see that I need to move it once and twice to get to here, right? So I basically moved it twice, right? So this is going to be 6.93 times 10. Is it to the second power? Yes, it's going to be second power because we moved it twice. But remember, we are making the decimal smaller, so it's got to be -2. Okay. Number 4. Let's see. It is 0.000693. Okay. Same idea here, right? We look back at the original decimal, 6.93, right? How many times do I gotta move it to look like this, right? So let's see. I'm just writing out the zeros, and then we can see, right, what's going on. So we have to move it once, twice, 3 times, 4 times, right? So what does that mean? That means 6.93 still is the same, right? This is the same for all of them. Times 10. How many times did we move it? Well, 4 times, right? It was 1, 2, 3, 4. Now, did we move to the left or to the right? Well, move to the left, right? Because my decimal is getting smaller, so it's going to be -4. Okay. Let's just do one more. Let's see. Actually, we'll do 2 more. Okay. It's only 2 more questions. 693,000. Okay. Okay, once again, 6.93. How many zeros are there? 1, 2, 3, right? This is 6.93 times 10, right? Once again, is my number getting bigger or smaller? Or is my decimal getting bigger or smaller? Well, it's getting bigger, right? So we gotta move to the right, right? So let's see how many times. We see 1, 2, 3, 4, 5. So this is basically 10 to the 5, right? And it's positive, remember, because my decimal's getting bigger. Okay. And then last but not least, let me just erase this. Last but not least, we have 6, and it's just 6.93. Okay. So as you can see, the decimal is the same, right? So 10 to the what power makes 6.93 the same? Well, any number multiplied by 1 is itself, right? So it's just 6.93, right? Times 10 to the 0. Okay. 10 to the 0 is 1. So 1 times 6.93 is 6.93. Basically, we didn't do anything. Didn't change anything. Okay, and then now we will do a few questions where we will write out the number in ordinary decimal notation. Okay. Actually, no, we won't do that. We'll do something a little bit different. For now, we will be just writing down random numbers, and then we will be converting it into scientific notation. Okay. So the first one says, in a year, light travels approximately this huge number of meters. So let's type this. In a year, light travels approximately 9,5, 0, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So let's extend this out. Number 0, 3, 6, 9, 12. 3, 6, 9, 12 meters. Okay. So I don't even know how to read this number. Okay. But we got to make this into scientific notation. So remember, it's always in the form of a times 10 to the n, right? So a has to be a number between 1 through 10, right? Less than 10, greater than or equal to 1. So we look at the numbers that we see here. We see that 9 and 5, right? So we could write automatically 9.5, okay? But then we need to ask ourselves, how many times do I have to move the decimal to get to this huge number, right? So let's just write down the zeros that we see. So 1, 2, 1, 2, 3, right? 1, 2, 3, right? 1, 2, 3. That's one set, 2 set, 3 sets, one more set of zeros. All right, so there's 4, 3 zeros. Okay, good. Now, so how do I get this to look like this, right? Well, I have to move my decimal how many times? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's basically 9.5 times 10 to the 14 power, right? Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? Is it 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sorry, it's 15. I was still out of zeros. So 9.5 times 10 to the 15 is equal to this. Okay. Another one we have is, let me just erase this. Delete. Another question we have is 1 gram is about 0.035 ounces. Okay, so once again, we look at the numbers. We see only 3 and 5, so our decimal is going to be 3.5, right? And we want to make it look like 0.035. So we have to move the decimal how many times? 1, 2 to the left. So it's going to be a negative, right? So it's going to be 3.5 times, remember it's always 10, right? 2 the negative 2, right? Because I moved 2 times to the left. Okay. Next one, 1 micron equals 3.123 4 6. So here it says 1 micron equals 2.00003937 inch. Okay. So we look at the decimal we see, right? I'll take the first digit and make a decimal afterwards. So it's 3.937 times 10 to the n, right? But it's 0.00. So sorry. So it's 0.937, right? So how do I get it to look like this, right? 40. So we look. Take the decimal. How many do we move left or right? Well, left, right? 1, 2, 3, 4, 5. So this is going to be 3.937 times 10 to the negative 5. Okay. As you can see, we asked ourselves how many times is the decimal being moved, right? So 1, 2, 3, 4, 5. Is it going left? If it's left, it's going to be a negative exponent. If it's to the right, it's going to be a positive exponent. All right. All right. That's pretty much it for today. Thank you for watching. Take care. Bye-bye.